Hello everybody and welcome back to How to CMake Good. We're now in part 0D, and you'll notice we're back on Windows again. That's because, as promised, I'm going to show you how you can use Visual C++ without using Visual Studio. In fact, you won't even need an IDE. This is very important when you want to set up a CI system and use Visual C++ without having to set up and use the IDE to compile all your code. We've seen that you can just use MSBuild from CMake to just compile and link your projects, and that'll work just fine. But for many, MSBuild has a lot of downsides, and they'd rather use another tool, like Ninja. I'll also be talking about how to do Ninja with Visual C++ today. The terminology and branding around Visual C++ and Visual Studio might be a little confusing for some. The name Visual Studio refers to the entire suite of products, as well as the IDE that acts as the front end to those products. Visual C++ is the name of the toolchain used for C++ programs and projects. Visual C++ will also often be shortened to MSVC, or Microsoft Visual C++. Just like with GCC and Clang, Visual C++ also has a command line. The command line program is called cl.exe. The linker is called link.exe. For a given Visual C++ installation, you'll probably have multiple cl.exe and link.exe executables. These each service different architectures and target different platforms. I've created a simple main.cpp and saved it to my disk. We can start a command window and try to execute cl.exe on this file, but it won't work. I can type the full path to the Visual C++ cl.exe and execute it just like any regular program. It prints a simple help message if we run it with no arguments. We can also get all the help options with the /? standard Windows help option. The online documentation might be easier to read, but you can use / to get a quick overview of all the options that cl.exe accepts. So if I try to pass main.cpp to cl.exe, it won't compile it properly. It generates a special error message, no include path set, and this literally means exactly what it says on the tin. There is no include path set for the compiler. Unlike GCC and Clang, cl.exe has no built-in default include path. You need to either set it from the command line or a special environment variable that cl.exe will check and use when it does the search. The easiest way to set these environment variables is to start with a Visual Studio developer command prompt. You can find it in the Visual Studio directory of your programs. I'll expand Visual Studio 2017, and we see these developer tools command prompts if you've installed the Visual C++ tools. I'll launch the x64 native tools command prompt for VS. It prints this message about being a Visual Studio 2017 developer command prompt. It also prints a vcvarsol.bat environment initialized for x64. This comes from a batch file included in Visual Studio distributions that will set the environment variables necessary to compile and link programs. I can now execute cl.exe directly without specifying the absolute path. I'll change into the directory where I've written this main file. I'll run cl on the main.cpp, and it will compile and link an executable. I can execute this program just as you'd expect, and it prints hello world. We didn't use Visual Studio, we didn't generate any build system, we compiled and linked this program manually all on our own. I'll now launch PowerShell so we can look at the environment variables. ls env, and here's all the environment variables present. The important ones are here: include, lib, libpath, as well as a few others that direct the compiler and linker on where to search for certain files. If I print the include environment variable, it's a semicolon-separated list of directories where Visual C++ will look for include files by default. Similar to include is lib. If I print this one, this is a semicolon-separated list of directories where the linker will search for library files. We've run the command prompt from the shortcut, but we can also start a new command prompt from an existing command prompt. This may be required if you don't have control over what command window is started by your continuous integration system. We do that by calling that vcvarsol.bat that's included with Visual Studio. The location of the vcvarsol will vary based on your Visual Studio version, so take a look around and use the Windows Explorer search tool to find it. I know the path to mine, so I'll type it now. This is the vcvarsol.bat file that's included with the Visual Studio 2017 build tools. If I execute it without any arguments, it'll print a simple help message. This is the list of options you can pass to the vcvarsol batch script to control what architecture, platform, Windows SDK, and Visual C++ version you'll be using. The simplest is to pass either x86 or x64. I'll pass x64. It prints the same header and message that we saw from the Visual Studio Developer command prompt shortcut we ran. And now, cl.exe is on my path and ready to use. I'll cd into dev vc test, and I'll compile the program again from a regular command prompt. Visual Studio also comes with a program called NMake. NMake is a partial reimplementation of the standard Unix make. I'll go to an already existing CMake project and attempt to build it using NMake. I'll build CMake itself using CMake and NMake. Make-dir-build, cd-build, CMake, and here's the special option, -G, NMake, MakeFiles, ... Press enter, and it'll configure using NMake as the target generator. Instead of producing MSBuild build files, it will produce NMake format makefiles that can be executed with NMake. Wow, that took several minutes. I didn't actually expect it to take that long, but that'll be a good benchmark for later. I'll open a file explorer in this directory. You can find down below a makefile. This isn't a standard makefile and it's meant to be run by NMake. I'll ask NMake to build the CMake executable for us. I'm also going to start a timer just so we can see how long that's taking. Here we go. See you in an hour. Alright, so it's been building for 10 minutes and I got impatient, but let the record show that 10 minutes and it still hasn't finished. Now I'll do a quick comparison with the MSBuild based build. I'll wipe the build directory and run CMake again. Okay, so that configure took even longer than it did with NMake. I'll start the build and start a timer for it, just like we did with NMake. So that was a build of CMake using MSBuild. That'll be the same build speed you'll get using the Visual Studio IDE since it uses MSBuild under the hood. And that took a total of 9 minutes and 2 seconds, as MSBuild printed for us here, so the timer wasn't necessary. But that's still pretty slow, and the configure took a very, very long time too. So what can we do about this? Well, there's another option that's gaining popularity and is very easy to use. I'll just jump right into using it. I'll go to my build directory, clear it all out, and configure the project using Ninja. Oh, it tried to use GCC. This is a behavior of CMake to try to use GCC when using makefile generators. Ninja is counted as a makefile generator, even though it doesn't emit makefile style build files. I'll wipe the bad build files from my build directory and try again by specifying the CMake C compiler to be CL and the CMake CXX compiler to be CL as well. Start the configure and it'll go right into using MSVC with Ninja. So that was CMake configured with the Ninja generator. I didn't run a timer for them, but I'll put the times on the screen, and you can see that Ninja configured the project much faster than Visual Studio or NMake. This is because that during these compilation tests, CMake generates a small CMake project and tries to build and compile it. Now I'll run Ninja and we'll time that to see how fast it builds. It's as simple as typing Ninja, then the target to build. So that was the Ninja build of CMake. It took about 3.5 minutes, almost 3 times as fast as the Visual Studio build, and much faster than the NMake build. Ninja is inherently much faster because it's targeted specifically at compiling large numbers of source files in parallel, as fast as it can. Ninja was originally developed for the Chromium project to build the web browser because Chrome has an enormous number of source files, and it benefits greatly from being able to compile them in parallel. Using Ninja is extremely simple. If I ask for the Ninja command, you can see it is c:/bin/ninja.exe. c:/bin is a path that I've added to my system path so that it is searched for when I type commands. It's as simple as downloading the executable file and placing it on your path. This works the same on Windows, macOS, and Linux. All you need to do is go to the Ninja GitHub, go to the releases page, download the executable for your platform, and place it somewhere on a path that you can access from the command line. Then you're ready to use it with CMake. All you need to do is pass G Ninja when you want to configure your project. That's all for this video. Check the video description for any addenda, errata, extra information, or important links. Thanks for watching, and until next time, keep CMaking good.